Hi everyone, I'm Fen Chi Yong, R&D Director in Manisplendid Infotech company. I'm very great to represent my team to introduce the Wisdom technique. In this presentation, we first brief how to retrieve three-dimensional wind fields with radar observations in traditional dual Doppler wind synthesis and its limitations. And then we will introduce the Wisdom technique, a variation-based multiple Doppler radar wind synthesis system, and the operational version in Central Weather Bureau. Finally, we will give some conclusions. Radar transmits electromagnetic wave and analyzes the return signal to probe the internal structure of the weather system. Using Doppler effect to measure the wind when the target is moving, the return frequency will be changed according to the moving speed of the target. In the animation below, the frequency of return signals received in the left-hand side radar is getting lower. Meanwhile, the ones received in the right-hand side radar get higher and higher. Therefore, we can retrieve the radial component of the moving speed of the target. This is the radial wind VR in the right picture. The relation between VR and the three-dimensional wind field UVW can be described by the following equation. In the equation, Vt is the range of terminal velocity, and the xyz is the range of position vector relative to the radar in Cartesian coordinate. Although VR is known, but UVW remains unknown. We need multiple radars to synthesize the wind field. There are 20 ground-based radars in Taiwan, which belongs to CWB, NCU, CAA, Air Force, and NEO Labs. Two more will be built in the near future. The entire whole operational radar network is very suitable to construct real-time three-dimensional wind field. The traditional three-dimensional wind synthesis methods uses dual Doppler observations. First, neglect W. Second, use two equations to compute U and V, and then update W. These three steps form an iteration loop. However, the denominator will be almost zero along or near the radar baseline, which is cause the above two equations failure. Limitation of traditional method including area needs to be covered by both radars, cannot recover the wind along baseline. Errors will be accumulated due to incorrect assumption for W. And also, it cannot retrieve the wind along terrain. Therefore, Professor Liao and the research team in National Central University proposed a variational-based multiple Doppler wind synthesis technique. Wind synthesis system using Doppler measurement, abbreviated to Wisdom. Using two volume scans of N radars observations, Wisdom variationally minimizes cost function J to get a three-dimensional wind field UVW. Cost function J contains 5 equations to be satisfied at the same time. N can be any number beta greater than 2. In 2008 Southwest Monsoon experiment, our team used RCCG and S-Pole radar data to retrieve the whole 3-dimensional wind field in the southwest region of Taiwan successfully, which reveals correct wind structure along the baseline. The results have been published in Monthly Weather Review 2009. The left side figure demonstrates 2.5 km high wind field retrieved by Wisdom, and the right side figure is the one done by traditional method, CIGIC, which featured as a blank region and a distorted wind structure in the vicinity. During 2018 Winter Olympics, Korea Meteorological Administration had applied Wisdom to monitor real-time 3-dimensional wind field around ski jumping site to ensure the safety of athletes. After that, KMA built an operational version of Wisdom on supercomputer for regular weather affairs, which update the 3-dimensional wind field of the entire Korea Peninsula every 5 minutes. Here is some information about the spacing, number of grids. In Taiwan, Central Weather Bureau and NCDR also built operational versions of Wisdom since 2020 summer. CWB used 8 radars for retrieving real-time 3-dimensional wind field in 2 different domains for Wisdom operation and updating every 10 minutes. Here is some information about the spacing, number of grids. To meet the requirement of updating every 10 minutes, the CPU and the GPU parallel computing architecture is implemented to improve the efficiency of Wisdom calculation significantly on regular server. For CPU parallel computing, we use OpenMP multi-thread technique. For GPU parallel computing, we use NVIDIA CUDA Fortran. Also, the CPU and the GPU unsynchronized data transfer technique is applied to make the data transfer and computing concurrent. This slide demonstrates retrieved 10 minutes interval wind field and the reflectivity at different height for 0 to 20 local time in 2020, October 26. From left to right is the 1 km to 0.0 km high, namely. Zoom in the southwest region and focus on the 1.26 0 km high, we can see there are strong convective systems occurred continuously when the weather system approaching the land, which matches the retrieval 3-dimensional wind structure. When we analyze the vertical profile along 23.5 and 23 and 22.5 latitude, we can see the U and W match the life cycle of convective systems. To summarize, using Wisdom to retrieve 3-dimensional wind field has several advantages. First, it can recover 3-dimensional winds along and near baseline. Second, in addition to continuity equation, retrieved three-dimensional wind also satisfies vorticity equation, can be readily used for vorticity budget analysis and thermodynamic retrieval. And 3, it can merge all available wind information from radar profile, sounding, surface station, NWP model output, and satellite data. Finally, it can produce high-resolution, temporal, and spatial three-dimensional wind field for severe weather monitoring and scientific research. Thank you.